Hey, maybe this will just be a one question video. I already started. I forgot to hit the record button. So, yeah, recording now. So, the question was let me read this question. This is question number 5 on the sheet. Number 5. And the question asks us to find the area bounded by the ellipse given by these two parametric equations where t runs between 0 and pi. And the theorem in the book tells us we can calculate it simply by doing this. And I say simply because, there's always a catch. The theorem says if you have the parametric equations and they're going to run between these values of t, these a and b will give us the limits of integration. And we'll just plug in the function for y and multiply it by the derivative with respect to t of the function for x. And there you go. Of course, then the question is, can you do the integration? That's why, simple should be put in quotes. Here's the two functions. I took the derivative of x with respect to t. That's straightforward enough. I plug it in, here as per the formula. Sometimes sine is sine squared. I factor out the -4 just to get it out of the way. And then, kablamo, we're hit with this, which is a non-obvious integral. We could simply use a trig identity. We could cobble together fairly easy an identity for sine squared t. I think it would be in terms of cosine of 2t. But since I didn't ask that in the question, and, this is not really Calc 2, right? Frankly, you go ahead and solve this any way you want. I wrote down, to be honest, what I did, I know how I would attack this. If I didn't have a trig table at hand, I would do trig identity, and hopefully I would get some easy integrations. But I do have integral tables at hand, so I looked it up right here, and it tells me to get the indefinite integral, what am I going to do? I'm just going to take this value of u, put it there, sine of 2au, blah, blah, blah. It tells me what to do. In terms of this formula right here, what is the a? If you look at it over there, for this particular setup right here, a is 1. And then t just takes the place of u. So what this means is this is going to be equal to -4. I mean, that's just out in front. And then we'll put these little brackets here. What did we say u was? U was t, so t over 2 minus sine of 2 times 1 times u, so 2t, divided by 4. And that's evaluated between 0 and pi. And let's go ahead and do the calculations, and then we'll be done, amazingly. The area is equal to that. Let's see, this is equal to -4 times, first we'll put the pi in, right? So pi over 2. Pi over 2 minus, if I put a pi in here, we have sine of 2 pi. What's the sine of 2 pi? 0. So actually that all goes to 0. And then minus, this is interesting here. I don't know if you're seeing what I'm seeing. It makes this interesting, but we'll see in a second here. Minus, maybe I could put that all in parentheses there like that. Minus, let's put a 0 in there. So you get 0 divided by 0. Minus, put a 0 in there, you get 0. And I'm not feeling too happy about this right now because that goes away. That's 0. We do a little bit of canceling here. And lo and behold, we get -2 pi. And why am I not happy about that? Well, I'm not happy because last time I checked, areas should not be negative. Now, we could take the usual student approach here and just do this. Let's see if this is visible here. We just come over, and when nobody's looking, we do that kind of thing. Or we could try to backtrack and see if we've made an error. Or maybe I should go back to the original theorem and see if it involves some absolute values. Or if the theorem has other conditions that I didn't write down carefully enough. So let me go back to the theorem. I should tell you this is theorem. Here, I'll tell you where this is in the book. This is in this right here. This is from section 1.2. And it is, where do we go here? It is It is theorem 1.2. Wow, that's awkward enough, but okay, theorem 1.2. And it says, consider the non-self-intersecting plane curve defined by the parametric equations. Now, we probably should make a graph of this, and actually I did, and I honestly just used Desmos. If you want, I can talk about it in class or whatever. How would you graph it without Desmos? But right now, let's just go ahead and use Desmos. And I'll tell you what the graph looks like. It looks like this. I want to make sure I entered it in correctly. X is cosine of t. Y is 4 sine of t. And it looks like this. There's a pretty rough graph. It looks like that. I don't mean that it's a parabola. As a matter of fact, it's half of an ellipse. And if I look a little more closely, this intersects at 1 and over here at -1. And up here at 1, 2, 3, 4. So we're trying to find the area. Actually, we do have to be a little bit careful, like which area are we talking about? Well, it's the area under this curve. So it's not, did I say an area bounded by the ellipse? Well, you could have me on a technicality here. I should have said bounded by the ellipse and above the x-axis, if we meant this area right here. Now, clearly that area is, it's not negative. I wouldn't know what sense to make out of it if it's negative. So this is where I start to check my sanity. And if you watch the previous video, I made an incredibly silly mistake, and I honestly couldn't find it for a minute. I had to go lie down and then drink a cup of tea and then come back, and then it was clearly obvious to me. If you were all gathered here, maybe you would point out some unbelievably silly mistake that I'm making. Last time I checked, when you take the derivative of cosine, it is negative sine. And I have no doubt about that. Sine times sine is sine squared. This is a negative times a positive, so it's a negative. I factor the -4 out in front. As far as this is a formula for, an antiderivative and indefinite integral. And I'm pretty sure I copied that really, really, really carefully from the book. So I'm actually not sure why I'm getting a negative sign here. So if you're watching this and you want some mega extra credit, see if you can find my error. I probably will. I'll stop this video now, and I bet like in 10 minutes I'll say, oh, there's the mistake. Completely ridiculous, but nonetheless, okay, so there's the area. It's a negative area, and we can contemplate what that means. Hey, one comment about this. This is the sort of problem here where there's a lot of theory built up here. I mean, by the time you write something down like this, think of all the math that went into writing down something like this. And oftentimes there can be a lot of conditions. As I read this, so, if I had to, if my life depended on it, I would go back and I would reprove that theorem, and in proving it, I'm sure I would pick up on all the conditions that have to be met. Sometimes you have conditions on X and Y. Maybe they have to be positive. Maybe one has to be greater than the other. There was a condition here that this curve does not intersect itself. In other words, the curve doesn't do something like that. Well, it doesn't do something like that. So, that's not really a problem. So, hey, I'll leave this one here. That's enough for one video. I'll come back and we'll do question number 6, which is another area question. But this time it's an equation given by polar coordinates.